You and I, we move through the world in 3D without a second thought. It's just natural. But for an artificial intelligence, seeing in 3 dimensions is an absolutely massive challenge. So what happens when that AI's vision breaks, when a self-driving car gets lost, or a robot completely misjudges a space? How in the world do you fix a problem you can't even see?
And that, right there, is the huge problem for the engineers who are building our future. See, when an AI's 3D perception fails, it's not as simple as finding a bug in a line of code. Nope. The developers have to become detectives, hunting for these tiny, almost invisible clues in a giant sea of super complex data.
So why is this so hard? I mean, what's the big deal? Well, it really comes down to this massive leap in complexity. A 2D image, that's just a flat snapshot in time. But the real world, it's got depth, it's got movement, and it's got context that changes from one second to the next.
Okay, so the key idea to wrap your head around is something called spatio-temporal context. It sounds complicated, but it's not. Spatio is just about space, where something is. And temporal is about time, how it's moving or changing. And AI has to get both of these right all the time to make sense of our world. And it's right there in that connection between space and time that the trickiest, most frustrating bugs love to hide.
And this is where we hit the real heart of the problem. You've got these brilliant developers trying to solve these deep, 3D spatio-temporal problems, but they're basically stuck using flat 2D tools. I mean, imagine trying to figure out why a car engine is knocking by only looking at spreadsheets and a few photos. There's this huge disconnect.
In fact, researchers sat down with a bunch of computer vision engineers and basically asked, what's driving you crazy? And it boiled down to 3 big things. First, just getting their hands on that crucial spatio-temporal context is a real pain. Second, they're juggling all this different data, video feeds, sensor readings, 3D maps, and getting it all to play nicely together is a total nightmare. And third, that connection between their 2D charts and the 3D world they're trying to fix, it's weak, really weak.
This quote just nails the problem perfectly. Engineers have to literally stop everything they're doing, export a bunch of data, and open a totally separate program like Blender just to see what's going on in 3D. I mean, talk about a workflow killer. It just slams the brakes on any creative insight and makes that whole detective process slow and really, really inefficient.
So, what's the solution? Well, it's a whole new way of thinking called Immersive Analytics. The idea is simple, but whoa, it's profound. Instead of just looking at data on a screen from the outside, what if you could actually step inside the data itself?
Okay, so this happens in 3 stages, or levels. Level 1, that's the world we all know, the desktop. You've got your line graphs, your spreadsheets, and maybe a little 3D viewer window tucked in the corner of your monitor. That's our baseline.
All right, level 2 is where things start to get a little bit sci-fi. You put on a mixed reality headset, and suddenly those data windows break free from your monitor. They become these floating panels right there in your room. Your charts can be hovering right next to a 3D model of the environment. The data is no longer trapped inside a box.
And then there's level 3. This is full immersion. You put on the headset and bam, you're not in your office anymore. You are transported. You're standing inside a virtual reconstruction of the exact environment where the AI was operating. You are literally walking around inside the data.
So to really see how powerful this is, let's follow an engineer on a real bug hunt. Think of it like a virtual detective story taken straight from a recent study.
So our story starts just like any good mystery, with a single weird clue. The engineer is looking at a pretty standard 2D chart of sensor data, and he spots these 2 suspicious little peaks in something called gravity deviation. Basically, it's a measure of how the AI thinks it's oriented. It's a tiny, tiny anomaly, but it's the thread he's going to pull.
So to figure out what caused those peaks, he doesn't just zoom in on the graph. No way. He puts on the headset and literally enters the crime scene, a full VR model of the house where that data was recorded. Right away, he suspects it has something to do with the staircase.
But here's the twist in our story. He looks at all the standard performance metrics, the usual suspects for errors, and they all look perfectly fine around the staircase. His first guess seems to be a bust. The mystery just got a lot more interesting.
And this is the aha moment. He pulls up a brand new custom visualization that compares the AI's predicted path with the actual real path. The people in the study called it the butterfly visualization. And all of a sudden, the invisible becomes visible. He can clearly see this subtle drift error. The AI's path is just slightly but consistently off from reality. This was a silent failure, completely missed by all the standard tools.
So, to seal the deal, to crack this case wide open, he navigates in VR over to where that second data spike happened, right at the top of the stairs. And bingo, he sees the exact same butterfly error. The pattern is confirmed. He's found the ghost in the machine, a bug that nobody could see before.
So what does all this mean? This isn't just some cool new gadget. It's a fundamental shift in how we understand and, yeah, how we fix artificial intelligence. It's about getting to see the world for the very first time through an AI's own eyes.
And you know, the engineers who used this in the study, they were blown away. They said they had a much better feel for the 3D space, that they could compare different data views way more easily, and that it just boosted their own human intuition for spotting problems. In fact, they called it significantly superior for this kind of complex work. And there's this one quote from a participant that just perfectly sums it all up. He said, "It's better to inspect their alignment with your own spatial intuition." That's the magic right there. This tech doesn't replace the human expert, it supercharges them. It connects the AI's digital world to our own natural built-in talent for understanding 3D space.
And that leaves us with this incredible, kind of mind-bending question for the future. For years, we've been trying so hard to get AI to understand our world. Now, for the first time, we can actually step into its world. So if we can enter an AI's perception to find its flaws, just imagine what other secrets, what other brilliant insights are just waiting in there for us to discover.